Right, so here was a second fallacy that I showed you, and it was pretty neat because, you know, I could bring negatives into there, or you could add 1 to both sides and show that 2 is equal to 0, which is even more confusing than 2 being equal to 1, at least they're both positive. What's wrong with this, okay? Now, I've numbered the lines all again so you can identify. There are a couple of places that people saw that there were problems, right? Now, most people can see, if you have a look at 5, 6, and 7, right? Once you get to line 5, it's pretty much over. I've already gotten it all sewn up because line 5, line 6, line 7, nothing dramatic happens. What happens in here? You're just evaluating numbers. And you can use a calculator to check if you don't trust those values for the trig ratios, okay? From here to here, just in the same way, nothing very much dramatic takes place. 1 minus 0, pretty sure is 1, and the square root is 1, okay? So what's gone wrong here, okay? Clearly it's earlier than line 5, so the most natural explanation for where this has gone funny is up here in line 4. So people say, there's your problem, okay? Theta is equal to 180 degrees, and most people think, aha, I'm onto something, because the original proof I gave you for this result used this triangle, right? So if you have theta down here and you make the hypotenuse 1, then you're going to have sine theta over here, cos theta over here, use that for Pythagoras, but theta equal to 180 can't happen in this triangle. Actually, it can't happen in any triangle because the whole angle sum has to equal 180 degrees. You can't have 180 degrees in one and then 0 degrees for the other, 0 degrees for the other angle. That's not a triangle, okay? So most people think, aha, this must be the issue, okay? Now, that's close, but no cigar. The reason why is that, you might recall, I told you this was a kind of cheap and nasty way to prove this identity, but this identity is actually true for all values of theta. Any value you throw in there, no matter how big it is, like even if it's 500 degrees, which can't even fit in the triangle, it'll still work, okay? And you can check this out, right? You can pop the 180 degrees up into here and verify that sine 180 degrees is 0 and cos theta is -1, so when you square it you get 1, so sure enough, it's 1, okay? So where's the issue? Now, lots of people said to me, okay, I know it's not 4, but something sneaky has happened between line 2 and line 3. There should be a plus or minus, okay? There should be a plus or minus. But this then raised the question of, most people couldn't explain to me, why should there be a plus or minus? Like they knew it's because something to do with the square root, but like why? I mean, they didn't say, if I gave you this, and this is the example I actually said to people, right? I've got two things and they're equal, no problems, right? So that's 25, right? And that's, I'll just leave that as 5 squared. Now if I take the square root of both sides, right? You wouldn't say 5 equals plus or minus 5, right? But this line here looks very similar to this. You've got no plus or minus there, the positive value, right? Then you go plus or minus on here. Well, clearly 5 is not equal to -5. So if you're not going to put a plus or minus there, why would you bother to put one over there? And here's why, okay? The reason why this doesn't make sense to put a plus or minus on this equation, right? But not on this one, is that unlike 5, cos theta is not just any ordinary number. I gave you a clue about this when I showed you the graph of what cos looked like before. It looks like this. That's 360 degrees. Okay, there's 180 in the middle. Right? Cos theta is not just any number. You can see in between 90 degrees and 270 degrees, cos is negative, right? You might even remember this from your quadrants diagram. See, positive here, but not there. Okay. So therefore, this line to this line is a bit sneaky, right? It is plus or minus depending on what value of theta you actually put into there, okay? So that's why there's an issue kind of with here, but only because of what we said in the previous line. And that's how you can come up with nonsensical results like that.